Hello, everyone. Thanks for coming. We're going to talk about Secure by Default distro for curing container CVE chaos. I'm James Strong. I'm a solutions architect for ChainGuard.
And I am Carlos. I'm a software engineer at ChainGuard as well.
So before we get started, I want to have a little fun with this one. How many CVEs are in the Docker Hub nginx container right now? Many. Okay. I can tell you exactly how many are in the ChainGuard image. That many. I actually want to show you before we get started. So we've been having some fun with this. So let's go ahead and we'll just run it on the nginx one. So we use Trivy and Gripe for the open source scanners. So we also put out our own security advisories, so they pull in all of the CVE and fixes for our images. So let's see how long this is gonna take now that I... You can do it. Come on, Trivy. This is why you record things and make GIFs of things. There we go. That's a lot. We'll get there. 113. That was more than the last time I looked at it. It was 103. So let's go look at the ChainGuard image. Typing is hard when people are watching. That's not a lot. Anyway, so that's the crux of our talk. Thank you for coming. Kidding. So as I was talking about, I help secure containers at ChainGuard. I'm also the Ingress nginx maintainer, and yes, I know there are CVEs in that container image, and we are working very hard to fix those. And I'm also the author of Networking in Kubernetes.
And I'm part of the SIG release on Kubernetes as a tech lead as well, and also the member of the steering committee. At ChainGuard, they do take care of the releasing stuff, whether all the stuff we release. And on my free time, I do barbecue and latte art.
So like I said, we work at ChainGuard, and we are trying to make the software supply chain secure by default. And one of the things that we do there is by making code as secure as possible. We do a lot with a lot of open source tools that we'll talk about further along in the talk. So SBOMs using Sigstore. Has anybody heard of Sigstore? Anybody signing their containers with Sigstore? Awesome, awesome. We're not going to talk about Enforce today, but we're going to talk about our product offering for images that's built on top of all of these open source products that we're going to talk about. And really, we're going to talk about Wolfi from a container Linux perspective. But when we talk about that, I forgot I added these. So more CVE images. So I think this is the Go one. Yeah, Go. So that's got a lot. Ours has the same number, the same number. Nginx, PHP, those are just some of the ones on the top of our list. So we rebuild a lot of the open source world. So a lot of the GNU tools we rebuild. I think we're going to try to rebuild everything in the CNCF landscape. Not 100% there yet, but we will be. A lot of you are probably thinking, no way. Don't do that. That's why I wanted to open it up with doing the CVE scan so you can see in real time that there are no CVEs in them. So when we get really to the agenda, we're going to talk about Wolfi OS. That's the Linux, what we call undistribution that we do, how we work and build these images, how we have no CVEs in them, and we'll talk about the underlying open source tools, Melange and Apko, and then we'll do a little bit more demos. So what is a secure base image? We talk about that from a signed perspective. You want to be able to know where that container came from and who built it. So you want to be able to trace it all the way back to the source code and understand that the container image that you're running and that you've pulled from a registry is from the builder who built it, and not just something that someone built on their desktop or built on some CI server that was underneath someone's desk. And then we want to make sure that it's reliable and you understand exactly what's in it. And so that's what the SBOMs are for. So you can understand the specific versions, where it came from. Everything's all inside of that SBOM. And the way we work through this is with fast updates from upstream. So as soon as a patch is available, it's inside of our images within 24 hours. Even faster if it's a critical CVE or if there's an issue from a customer that asks us, we need this image patched today. Our answer for that is Wolfi. I forgot that, links through that. So who's heard of distro-less? So distro-less, that's a open source container images available. We say that it's V2 because distro-less does the same kind of ideas that we're talking about. It is specifically built for container images, doesn't have a kernel, only what's required to run the container image. We go above and beyond that with the security aspects that we've talked about, the SBOMs, the attestations, the CVE scans that are available. So that's why we call it distro-less V2. Undistro, because it's not specifically a Linux distribution. It is built specifically to run on container runtimes. It does not ship with the Linux kernel, so it relies on the underlying host for that. So again, only what is absolutely necessary to run the container. That's how we get this reduction in CVEs and reduction in sizes that we saw earlier. Rolling releases, we rebuild everything nightly. I think the last time I looked, oh no, for our customer images that we rebuild nightly, it takes about 40 minutes. I don't know how long it takes from the last time I looked to rebuild everything in our public image repository. But again, as patches are available, we have automation and bots in place that set up PRs and roll all of this through. So you can see all of this in GitHub. We use the APK package format. So one of the things that help people understand is that this is a drop-in replacement if you're using Alpine. It's, one of our engineers will probably yell at me when I say this, but it's a glibc replacement for Alpine. And we use the APK package. So we rebuild all of the source code in APKs. And like I talked about already, I probably said it 3 or 4 times, SBOMs for everything, so where the source code came from, who built it, and how it was built. Exactly, declarative and reproducible builds, so we should have the same outcome every single time that we build a package and then an image as well. Right now we currently only support x86, 64, and ARM. But why do we use APKs? Like we've talked about before, it's declarative and reproducible. It allows us to be able to replicate what's going on in the Alpine environment, and it doesn't leave the system. Using the design structures from APK, it does not leave the system in a broken state. So if an image tries to pull in a dependency that either isn't needed or is incompatible with another piece of software, the build breaks, and we have to go in and fix those things. Again, like APK, it resolves the world from that perspective. Here is the desired state of what I want, here's what it is, and we allow APK to do the work for us. We also have a pure Go implementation of the APK CLI, which is built into Melange to do all of this for us. And of course, because the way that it works from the world being the world resolution, if it's broken, we don't make the changes. Really, no rollbacks needed, because it doesn't produce the image, doesn't produce the binary. I've already done a bunch of the image scans. I put this in here before I thought I would start, but this is basically the same thing where I just started. I did it live instead. So, nginx latest. We're also, again, being able to reproduce and build all of these and only putting in exactly what's needed to run the applications. From an images perspective, dependencies perspective, the number of dependencies and the sizes is just smaller. Because again, we're not shipping everything that's in a Debian container or things like that. Right? Are you? No? Okay. It's not really magic. It's really just a bunch of Go code and, of course, more YAML, because we need that in our lives, right? If you go look at our public repository, if you have over 1,000 files in GitHub, it doesn't render all of them for you and gives you a little error every single time. It's fun every time I load that page. So I'm going to let Carlos talk about Melange and APKO.
Okay. Then these are the 2 tools that we use in a pipeline to produce all the in the end result the image. Melange is in the beginning is just like building the APK package and signing the APK index and all this stuff, and then it generates the the APK package for us, it's like a declarable pipeline. It's a YAML file again that you can like just declarative say what you want to do. And it's support multi-arch by default. It's like you can sign the APK package. You can, it auto-generate S-bonds as well. And like here is like just a simple example how we do it. We're gonna do a demo and then show how that works. And in the pipeline here, in this part of the config file, you explain how like you say like how you want to do the APK package. You fetch that for somewhere, and then you expected the SHA for that specific Git commit or something like that, and then you can run everything you needed. And in this part here in the run, you can set your compiler options. You can do whatever you want to do here. We have like shortcuts here, like for if you are building like a C++ or a C image, like you can use like just a pipeline CMake, and it already resolve everything for you. Do you want to go into this one?
Yeah, I can talk to this.
Yep.
So like Carlos was saying, and some of the things, so there are lots of options when you go to build software. We all know that. There's lots of options for GCC. There's lots of options for Go. And when we say secure by default, we're saying that when we build these softwares based on the pipelines that we have, these are the defaults. So being able to set up, the PIE, setting up the GCC compiler options, looking for those things. That's exactly what we do when we build those. So we change those options at build time, and you don't even have to think about it as a user who's building this package. You use the Go pipeline that we have. The Go pipeline sets all of those defaults for you. I was trying to think. We have pipelines for, I think, most of the major programming languages, learning how to build Python, Ruby gems, Rust, Go. I think we just now introduced a Perl pipeline, so for some reason, some of the images that we're building now require Perl. So that's fun. Learning how to build everyone's software is great. Yeah. We also have some Windows binaries. We're still working on the Windows support, but I think there is a .NET. We do have a .NET container image. One of the things that's very interesting is that we fix CVEs before NVD knows about it, or before the scanners even know about it. One of our recent case studies was this Go vulnerability, where I'm not going to read through this. Basically, it was just adding anonymous headers into there and allowing you to do things that you shouldn't be doing. Right? It's an option. We let people do that. But as soon as it was patched upstream, within 24 hours, it was already inside of our Go image. And then within that time frame, it also was in all of our Go images built using Go. So Cert Manager, etcd, Gatekeeper, all of our images were patched even before they showed up in the MVD and before they showed up in the scanners. So again, it's that quick reproducibility, that automation, and then just being able to push those out as soon as it's available from upstream. In very specific circumstances, we also will do the patches ourselves for certain customers. I don't think we have an instance where we've done a patch upstream just yet, but again, if it's needed, we can do that as well. But this is, again, we have a whole blog post about how this just works running through this, and it was just interesting to see that we have that capability in there. Okay.
That was Melange that builds out the APK package, and then you can push this package to the APK registry and make it public or private, you choose. And together with that, you need to push also the public key, because then when you download, if you, for example, want to use the Wolfi package in your Alpine stuff, you need to just say, okay, use this Wolfi public key as well to download all the packages and verify. After that, we have all the APKs in a registry and it's ready, or even locally if you want, because we're going to do this locally here. We need to build the image itself. We use APKO, and APKO is it's APK, and KO it's like a tool that exists in the Go ecosystem that builds image from the Go code itself. You don't need to use Docker files or whatever. You just pointing that to the, you just point your repository and run the KO, and it's gonna build output like a tiny Go image with your application side. The idea here is the same. Use APKs. We build the package in our OCI image. Like you can, like again, like Melange is reproducible by default. Here also is reproducible by default as well. And we generate attestation like provenance and S-bonds as well here. And we don't have like run statements like in a Docker file. And in the end, it generates like really tiny image comparing to like if you use a Docker file and then you need to download out. Imagine like in a normal Docker file, you need to, using Alpine, that you need to do Alpine get and install all the packages and then compile your code. You can do like in multi-stage builds as well, but there's sometimes a lot of layers. In our case, it's going to be just one layer with all the dependencies you need. And it's faster, like, because building this is super fast and take like milliseconds to build.
Depending on what network you're on.
Yeah, of course. And this is just like a simple configuration file for the APKO. You set the content, like what are the repositories you need, like the key ring for that repository. You can set up like multiple repositories here. Can be, in this case, is a public one, but you can have like private and other ones. So you can even have the Alpine one here. And here you also tell the package you are gonna need it. In this case, for example, is the CA certificate bundle and the reload server, which is the application you just built it. And here in below, you specify the groups and user and run, the runtime, which are the groups and the users that we're gonna run in your image. In the end, you just say the entry point, and that's it.
This one was, so like most tools or other things like that, we have the SDK image, which has APKO and Melange in there, so we can do development from these. APK, we used to have to be able to run this on Linux machines because we required APK, but now that we have the pure Go implementation, you can run APK from anywhere. So there's multiple different ways. You can use Melange and APKO directly as CLIs. We have container images where we build those, and we have the SDK image where we do most of our testing. So this just kind of wraps up how everything is created and worked through. So obviously all of this up here at the top is open source. So Melange, APKO, we have a community we're building around all of this, and then we have the public images that are available. So that nginx package, all of those, RabbitMQ, things like that, all of those are available for use. And then of course, being a company, you can pay you can pay ChainGuard for support with enterprise images. So we do anything that's available upstream. So like Kubernetes is N-3 or N-5, I can't remember, they're making changes. Go is N-2, so we support those versions from an open source perspective. And if you want anything older than that, you pay us for support. So that's how the business model works from an enterprise perspective. Let's talk a little bit about the supply chain security metadata, like we talked about, and we've continued to. We'll show it in the demo. So the signatures, right, are who built it. So we sign our images with the public instance from SigStore. So that provides you who built these images and where they came from, so you can verify that it did come from that. We also create the SBOM attestation, what was built. So everything that's in that APKO, it will also produce an SBOM for it as well. And then the provenance of how it was built. It will give you the commit SHA, the GitHub Action Runner ID, all of the information you would need to go look this up and be, okay, I can verify, and I can write policy, I can write Kverno policy, I can write, I think, yeah, not Kverno, yeah. SigStore, I can write policy controller policies and say, only run images that are signed from this CI perspective. There's a couple different options, right? So we said that it was a drop-in option. So if you're using Alpine, we have rebuilt, like I said, a lot of good new tools, all of the major Python programming languages. So if you needed a Ruby or Python, you can just do a drop-in replacement with Wolfi base. You can also build your own images, you can use APKO and Melange to build your own packages and your own container images. Again, another option here. Doesn't need a Docker daemon, no containers, no privileges, all of the fun stuff that we just talked about. Or you can just use the container images directly. If you want to learn more, we have the community options. Wolfi Dev OS is where we put all of the community APK packages that we've built, and you can pull those from. All of the images are in ChainGuard images. That is not the right link because it's missing. It's ChainGuard images / images. The URL should get you there. That's funny. So Carlos is going to do a demo on Melange or APKO, and I'm going to do the demo on verifying the supply chain from those. Before we get started with the demo, any questions before we jump in? Go ahead. I don't have the mic.
You mentioned that with one of the Go packages, you also updated essentially all of the reverse dependencies of that in a pretty short time span. Most of the Go packages pin the versions of the dependencies. Was this just a special case with the core libraries, or do you have some utility to update that?
So when we in Melange, we rebuilt Go with those packages. So it was with the latest one. So in the APKO, we're just pulling the latest. You can specify in APKO what version, but all of the rebuilds, we don't pin the version, so we're pulling the latest from our repositories. So we're rebuilding everything nightly, and so we just pull in the latest images nightly. And then we're just rebuilding, so like Cert Manager, we just rebuilt Cert Manager against our version of Go that we've built.
Yeah. So in that case, it worked probably because it's base library and comes with the compiler. But if it's some random Kubernetes client Go and the go.mod pins it to a previous version, you don't have automation to pull that up.
Yeah. So again, we pull the upstreams. So if the upstreams pinned it to Go 120, we'll use Go 120 to build that. Some cases we will break that and we'll force the upgrade. And we have our testing framework in place where we'll run, like Cert Manager, we'll make sure that we can pull it. So that's where we get the benefit of being able to have those 0 to low CVEs compared to what's in the wild.
Yeah. Okay, thank you.
I guess I have 2 questions. One is really basic. So just from my understanding, your approach to remediate the CVEs is just like drop everything you don't need, so you don't include most of the CVEs to begin with.
Yeah.
And like pull immediately from upstream when it's fixed, right? Okay. And so could you say that your plan is to basically create more distro-less default images for most of the applications that you think are important? Like, is that your goal?
Yes. We have the idea to rebuild the entire CNCF landscape on top of ChainGuard images. We actually had one customer ask us to rebuild Kubernetes, so to give them a Kubernetes distribution on top of ChainGuard images. So it's really, driven by what the open source is asking for, and also a combination of what customers are asking for. So we have, like I said, we have a lot of, obviously to do this, we've got to bootstrap and have a lot of the GNU tools available. So we have a lot of those from the Alpine world. We pull those in, we rebuild them. But yeah, it's a combination of those two. Eventually, that's one of the reasons why we're working through like our SOC 2 and our FIPS, getting FIPS images so that we can have everything be running on ChainGuard images. That's the goal.
Okay, we actually have a first for this conference, a question from the stream.
Oh, awesome.
So the question was, the problem with Alpine is that there's generally not reliably debug packages available for every package. Is that something that you would look into, providing a consistent debug package with every package? Or is that something you see as out of scope?
I wouldn't maybe this is just my lack of understanding of like the debug packages.
Debug symbols, basically.
Oh. You know?
For some packages, we
Because
expose
that is
the package
apparently
for the debugging
a pain
stuff.
point for a lot of Alpine users that other distributions provide consistent packages.
I couldn't tell you what the configuration options are for most of the tooling. It is available from the open source perspective, but again, it's the nice thing about those being open source is that people can put in pull requests and we can have those options available. So there is the idea of sub-packages, so like the development headers and things like that. So if there's an option where you could just have the debug option variant. So we do, from an images perspective, we do what we call like a dev variant, where it gives you a shell. Most of our containers do not have shells for that reason. Those are the ones you want to use in production. But from a Melange perspective, having the debug options, that's a good product question that I will definitely be taking back to the team. All right. We've been talking about it a lot. Go ahead.
Yeah. If you this is the repository you're going to use for the building the Melange and Apko image. You can scan here, or you can get later in the slides. But basically, these are the steps we are going to do. We have the code source in GitHub. Then we're going to run the Melange build that's going to pull up a specific version or a specific release or a specific commit we want, build the package, and then it's going to, in our case, going to be everything locally, but we depends on some public APK package as well that we're going to pull from the public APK repo, and there's going to be the input for the APKO to build that image. And then later on, we can push that image for a registry, a private or a public registry. In our case, we're not going to push. I don't think that internet is going to help us. But we're going to save the image in a tar format and then just Docker load in the end of the process. Okay. Control is control here? Yep.
Yeah. Tapping on someone else's laptop is fun.
Demo. Okay, first we are pulling the Melange Docker image because we are not going to use local stuff. We're going to use Docker. We're going to build inside the container. And this is pulling the Melange. Here as well, all the images are assigned with a cosign. We can verify those things here. We are not verifying this just for the demo purpose, but you can check those images are signed. Now we are running the Docker run and passing the Melange, and we are generating the keygen. This is going to generate the Melange keygens, the public and the private. That's going to be used to sign the APK package.
And unfortunately, because APK doesn't support SigStore or any other type of, we have to use key pairs for that.
Yeah. And now we're going to run the Melange build to build and passing the configuration file, and start building the repository. I'm going to show here while this is building the configuration for that, which is this one here. Okay. Here we define the package, and we say this is the name of the package we're going to produce. This is the version. This is the epoch, which if there is a patch or something, but it's in the underline we can just bump this one. A simple description of the package and the license we have here. And then the next field is the environment, where it's where they're gonna fetch things. We're gonna say here the repositories. This is the APK public repository, and this is the Wolfi signing key, the public one. And those are the packages we're gonna need to use to build that our application in this case. And here we can also set some environment variables. And then in the pipeline section, we have 3 steps here. This is a really simple, just output reload word. But we check out, and then we point out for the repository. We can say here, we are saying use the tag 123, in this case 0.1.0, and this is the expect commit we expected from that tag. If that changes, it's gonna break the build. That means someone hack or change the Git repository or something. And here we just run the Go build as a simple Go build. And in the last step, we remove all the path that we don't want it. And this is just this to build our APK package. And now it's downloading all the dependencies it needs from the public repository. I hope doesn't take that much.
Regarding the commit hashes, how often do you find dirty commits or tricks with tags nobody else discovered? Because nobody else built so much software.
We have a bot that takes care of a lot of that for us. So that's for on the changes. But if the build does break, yeah, someone's changed something underneath that we didn't expect. So that, I don't think I've seen that yet. Usually it's someone's either miscalculated something, because we're working on automating a lot of these, because a lot of it's a lot of repetitive YAML. But I don't think we've had an instance where there's been a security incident.
No, not yet.
Not yet.
Yeah. We're always hoping for the next, right? In our case here, we are using a tag. Like, we can specify a specific commit only instead of the tag. You can like build from this specific commit here. Or in this case, we are downloading by the tag, but we also and fetching for a GitHub repository. You can specify, for example, I was building the MySQL package yesterday, and I'm downloading from the MySQL repository from the FTP from there. Then it's not a GitHub package. Then we specify the path, and we specify the SHA-SUM that is expected for that targz. And it's not helping.
The network decided to stop working today.
Yeah, or the demo god is not in our side today.
Yeah. One of the things that we do when we're building, 1,000+ packages is we have a lot of caching. That's around, because really this is, on the back end, this is a GCP bucket. It's just hosting it. Go ahead.
Since this is taking a while either way, we got time to chat. Since you have CGO enabled 0, have you looked into the Go utility to build Go binaries that have essentially nothing outside the static binary, and have you compared just footprint of what you build here with what that outputs?
You're talking about the Go binaries that Go would produce versus what we would from this perspective?
Yeah, not just the binary, but the resulting container then.
I don't know if anybody's looked at that. Fortunately, we employ the maintainer for Go. So if there's a problem, we could fix it.
Yeah, APKO is heavily inspired in KO, and they use almost the similar approach to build the APK package, comparing to the Go package. I think it's almost there.
This is just the Melange build.
Maybe
this is definitely networking.
Yeah. Maybe you can show the...
I'll do the provenance stuff while we're waiting for that one to build, and as soon as we do, it's going to finish. So we've got a similar demo from the supply chain perspective. So, of course, these are all signed. From a SIG-store perspective, we're using cosign. So I have to authenticate to go download that one, and of course, it's going to be another network issue. My token probably just expired. So we're going to do a cosign verify on the nginx image. We have to tell cosign who we expect the ORDC issuer going to be, because we use keyless signing. So it's going to be coming from GitHub, because we use GitHub Actions to build all of our container images. And the certificate identity is going to be the workflow. So if we look at that, it's going to be our GitHub workflow at main for that, and we just give it the SHA. Of course, the internet decided not to work. There we go. I have to authenticate to cgr.dev. So that's what that one was. I've got them downloaded as well, so this is also just pulling down the SBOM from that perspective. I can show those while it's ran. So if we go look at the SPDX attestation, so this is the signed SBOM that we created. For that, you can just go and look and see everything that's available in the image, all of the files that are available, and the binaries that are, everything that was needed that was in there. One of the fun things, I don't think it's in this one, I think it's going to be in the provenance one. You can see the outputs of, again, it gave you the GitHub workflow SHA, the name of the workflow, the repository, everything of where it came from that perspective. So that's from the SBOM's perspective. I think we may have ran out of time. I see other people coming in, maybe. This is the provenance document that's pulled down as well, and it's created. So I'd go look at the SBOM. Got 3 minutes, thank you. So if I go look at the provenance document, again, everything that was pulled down to create the nginx image, the version, and then all of the other information. So this is the attestation that's available, so this should be able to go reproduce this, so you can go pull down and be able to build this if you want to. So you can see one of the things we didn't talk about is like it's very difficult to maintain and manage thousands of images, so we farmed out that graph dependency to Terraform. So we have an APKO provider, and then we just define all of these APKO YAMLs in Terraform, and we let Terraform build out all of our images for us. So that's why it said the builder ID is from the APKO provider.
Yeah, just one comment here. With this attestation, this provenance and SBOM, you can imagine you are running those images in your cluster. You can write policies to verify the provenance attestation. You can verify the SBOMs as well, to allow or block. Simple use case is when you deploy, check the SBOM and see if the version of libso is at least 123, for example. Otherwise, you can block that.
So again, the network's taking its sweet time trying to go download the Go binary to build this image. So unfortunately, you're not going to be able to see the full demo to build those. We showed you the Melange build where we'd say we need these things. Just go look at the APKO YAML. And again, it's very similar, right? We tell it, we built this locally. We need to pull the packages that aren't available. We define that repository that we've built, and we're just saying, hey, just go run and install these packages, everything that we've talked about. So that's not going to complete in the runtime.
Yeah, but all these steps are in the repository. You can go and clone that Git repo and run by yourself. Okay, we run out of time. Thank you.
Thanks, everyone.